All right, time for another draftphysics.com, debatephysics.com also. But again, the debaters just can't be dragged to the arena and argue the argument. So I'm going to take another try, another shot at this silly free momentum idea. So physics has lots of these different little ways of doing the same experiment. They're basically, okay, just hitting a small thing into a big thing. That's all they're really doing. All right, and they're saying that when that happens, you put more energy into the thing. So if they hit the worst case, okay, the worst example of their, I mean, this isn't an idea that only I shouldn't be the only person on this planet who can recognize that this theory of theirs doesn't make any sense. They say that I throw something at a brick wall, and if it bounces back with all of the energy, this 99% of it I get back, it means I put twice as much energy into the wall. So if the wall moves and I get less back, okay, that means less energy went into the wall, right? So the more it moves and the less I get back, the less energy goes into the wall. And the more the wall doesn't move and the more I get back, the more energy I put into the wall. I mean, it doesn't work that way. Nothing in my life ever worked that way. Nothing I ever noticed could possibly work that way. It just doesn't make any sense. There's 3 times the energy, essentially, right? I'm getting 100% back this way, and I put 200% into the wall for a grand total of 300. Now, these other experiments, okay, so say this is a 3 mass. If I can make it a 5 mass, okay, then I probably get up to that 2x number. But anyway, their theory is, okay, that the 100 goes in, hits the 5, okay, and that the 5 will shoot off with 150. Now, the simple change I'd make to the experiment, I mean, very simple change, is, just put another 100. So you have a 1 mass, these are 1 masses here. Just put the 1 mass a little bit further away. Now, we know if I have, I know I probably have to draw this for you because, I'm sorry, but people are freaking imbeciles. All right, so they're touching each other, right? So we know when they're touching each other, if I swing this one out here and I swing it in, that this one will pop out with 100. We know that'll happen, okay? So that's a certainty. So there shouldn't be any argument about that. If I put a solid object in between, I'm just going to get, just like a Newton's cradle, 100 in, 100 out. And so the idea is all I have to do is create a tiny bit of separation. So all I have to do is change the experiment a little tiny bit by having the 3 mass not, the 1 mass over here not touch. And if it doesn't touch, then I'm going to get this magical 150. All right, so if it doesn't touch, this will swing in. This will leave with 150. It'll hit this one, which means it's going to give it something, some percentage of what it has. And this one will keep going. And I'll have a total of 150 over here. That's their theory. You can't make any sense out of it. I mean, there's no logic here at all. I can't. What do you want me to say? It can't make any sense. All right. So and again, if I did it with a heavier mass, the 5 mass, I think, a 4 mass, I think, is 175, and a 5 mass would be 200%. So if you want to get 3 times the energy, that is, you want to have 200 going this way, momentum, all right, and 100 going this way, all you do is do the experiment, make a Newton's cradle with a big object in between the 2 one objects, go from 100, just that little tiny bit of space, the difference will be 100 to 300, a total amount of pressure in the universe, motion in the universe. I mean, how can this make any sense to you? I don't understand it. How can people sit here and say, okay, it makes perfectly good sense to me that, yes, if the wall moves, okay, and I get less energy back, okay, less energy came back, it means there's less energy in the system. And if the wall moves a lot, that is, I throw the thing and I get almost zero reflection, almost zero reflection, that I only put 100 in here. So I put 100 in, I only get 100 in movement in the object, So I get the least amount of energy if the object actually moves the other object, and I get the least, I get the most amount of energy if the object doesn't move at all. And it's not moving at all. I mean, it's sort of a giveaway. It's not moving at all when you get a perfect reflection. You can't get a perfect reflection if it moves. If this moves at all, this is not coming back with the 100, okay? This won't come back with 100, all right, if this wall moves at all. That everybody should be agreeable on. But somehow, the less it moves, the more energy I get into the wall. When the obvious answer is it's all it's doing reflecting. This isn't moving. The fact that it's not moving is telling you energy's not going in. It's just a fact. It's too big. It's too heavy. It's rejecting it. It's saying, I'm not going to tilt. I'm not going to vibrate. I'm not going to do any of that crap. You can have back what you threw in. Because I'm not accepting it. You can't move me. I'm too heavy. And so the other example is the anvil. So I throw that in just to give you a little verification that what they're saying is nutty. Okay, it's silly. It's just nonsense. I mean, really, come on, you people. I just know you're not this stupid. I know there's no way you're this stupid. You can't figure out, oh, okay, it seems obvious what's happening. All right, so if I take a steel surface that isn't perfect and a steel surface that is. So this is heat treated. It's really hard. Doesn't dent at all. This dents a little bit. You drop metal ball bearing or a glass. The silicas work the best. So if I use a hard enough, an undentable object and an undentable, so a dentable and a dentable, yeah, I'll get a few bounces and it runs out pretty quickly. Might get 10 bounces. But if I make this really hard, so I heat treat the steel, and I use the right kind of little object, I can get 200 reflections. Now, do you really think each time it's reflecting? Okay, so we'll do this, progressive thing. So 100 of these will be real bounces, and another 100 of them are going to be little tiny bounces. Okay, but the idea is you're going to get this back a lot of times. The energy is going to go back up again. Do you really think that each time the ball hit, it put twice the energy into here? So if it's just started with 100, you got 200, and then the second bounce you might get 180, and the third bounce you might get 160, then the fourth bounce 140. I mean, whatever you want to make up as numbers, but you're going to add up to a tremendous. You're going to get 10, 20, 30, 40 times the energy. Okay, will go into the surface. So you really believe that can happen? That I can put 40 times the joules or the watts. Okay, these are watts of energy. I can put 40 times the watts of energy that it took to throw the ball bearing at the surface. I mean, I could turn this horizontally and it'll do the same thing. So the idea, I could make a pendulum and it just hits a surface, right? So I just swing the pendulum, it hits the surface, and if it's hardened steel, bing, 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 it'll just keep bouncing 200 times, right? So that's the record I can find on YouTube. And yes, some of the bounces are really tiny, so we just eliminate half of them as really tiny. But you have legitimate bounces happening, okay? And that you're going to get, say, let's just go with the number 20 times. 20 times the energy, the watts, goes into this surface as heat than this contained to start with. You start with 100 and you have 2,000 watts goes into the surface. You believe that can happen? All right, so this goes back to they have air cart, and they have little cart experiments. And the carts are made by a company, and they have like 40 wheels on the cart, little metal wheels. Okay, so the carts are designed to do these type experiments, and the problem is that the wheels mean that any momentum you give the cart, like anytime you roll the cart, the linear momentum, that is its velocity in a linear direction, is only a portion of the energy the cart has. Because of the little metal wheels, it has stored a bunch of angular momentum in the rotation of the wheels. So it has more momentum than it appears to have. All right, because there's a bunch of it stored that you can't see. You can't see it as linear motion because it's stored as this circular motion. and you're only going to see it when it hits a surface, then this rotational energy will be converted into linear momentum. So even though its velocity was, say, x, its momentum when it hits a surface is going to be mass times velocity x plus, angular velocity y, or however you want to describe it. Okay, you have to add this extra component before you do your multiplication times the mass. You have to add the angular momentum. All right. So that's the reason why the card experiments can create free momentum, is because they have a bunch of stored momentum. And that at slow speeds, the stored momentum is very low. So the slower the motion, the lower the percentage of angular momentum. And the higher the velocity, the faster, the more angular momentum. All right, and then you have the air carts. And I've sort of explained that you can sort of imagine that, air carts are really nice, but that they have to be air tracks. They have to be precise, because any fluctuation in how the cart sits on the track, all right, any deviation from some sort of perfect. So here's the cart sitting on the track. You could sort of understand that the carts aren't moving on a frictionless surface that's benign. Okay, they're sitting on a cushion of air that's being created by a force being injected. So you're adding a force. All right, you're adding energy to this system. And your hope is that the carts will be equally affected by that system. And my argument is, well, no, depending on how this cart sits on this track, it's essentially got, if it tilts just a little, if it's a little heavier here than it is over here, it's going to have an exhaust, like a little jet engine, that's going to give it momentum. And so every time it hits something else, if it hits another cart, you can imagine that both carts might tilt up a little bit. They might push on each other, okay, and both of them lift. And so both carts will be given a little extra boost because they're both going to be creating exhausts. Quite conceivable. So you really do have to have as heavy as possible a cart that can't tilt, can't wobble. It's really a little delicate. So the $100, the $500 version of the experiment versus the $10,000, okay, they might behave a little different. Now, Professor Lewin used the $10,000 version, and he had to put clay on the thing, and he had to put extra weights on it, and had to do all kinds of crap to make it work. So anyway, but yeah, is there somewhere else I have to go with this? So this is just a classic fact. They say this happens. Okay, physics says this is how it works. You can make free momentum. It's a real thing. They'll do it right in front of your face. They'll say, look, we went in with this much energy, okay, this much movement in the universe, 100, and a little moment later, we're going to have 100 going this way, and we're going to have 150 going this way. We're going to have 200. We're going to double the amount of motion, matter moving in the universe. Here's point A, a fixed place in space. We had a case where only one thing was moving, and now you're going to have two things moving, and you're going to have twice as much energy than you started with. It's a free energy theory. I don't know why, and the very idea of saying something has momentum when it's not moving, I mean, shouldn't that be like what you call a non-starter? I mean, shouldn't everybody say, well, I'm not going to fall for that? I'm gullible, but I'm not that gullible. But no. Instead, they hurl insults in my direction. That's all I get. I don't get any kind of counter argument to any of the points made. They just insult me for not being as stupid and doopy as they are. Is there some other conclusion? Yeah, I don't think so. All right. So we'll leave it at that. No point in going over and over it. It's a tricky experiment to do, just because, you know, it's a little pendulums. You got to measure their distance. You got to get the height against gravity. You got to get all that just right to see how much momentum you have in the system. So it's a little delicate. All right. So anyway, till the next time and such and so forth and whatnot. Now, physicist Michael was supposed to have do the experiment, but we haven't heard from him in about a month. Maybe he's realizing something. I doubt it. You know, I try to get optimistic now and then, and, you know, allow myself to imagine that somebody will be persuaded. They'll logically reason it out and say there is something wrong. It just doesn't fit. All right, we need better evidence. We need more evidence. Because this stuff doesn't show up in reality. Like I said, again, I can show you car crashes. 50 miles an hour into a wall and then 100 miles into the wall, and there's no evidence of 4 times the energy. It doesn't show up anywhere. All right. So, until the next time and such, I can only do my part, people. You don't want to play along and be fair and reasonable. I can't do a damn thing about that. You want to be an asshole and say I haven't made an argument that's worth anybody addressing. It's not worth anybody explaining how I made a mistake somewhere in what I just explained. They're not required to. I haven't made a good enough argument to gain anybody's respect or appreciation that there's a real argument there. I mean, like I said, then you're just an asshole, frankly. I mean, you know, if that's what you think, it's not a good enough argument to be addressed. The simple truth. The fact that really nobody tells anybody not to drive fast because they're going to use up all their gasoline. The fact is the analysis isn't there. It doesn't work. Okay? You can't, you know, you're not going to have to use 25 times the electricity to spin a motor 5 times as fast. You're not going to have to do that. The physics says, and the physics is wrong. No professional bowler, no good bowler, can make the lighter ball knock down more pins, and it's supposed to be able to. How come? How come nobody can make that work? All right. Yeah. Spaceship. Okay. Are you going to deny that, you know, NASA has indicated it doesn't really play with modern physics when it comes to navigating in space? That it's, I mean, I could take a clip from the Gravity movie, right? And I could just point out to you that, you know, she's using a fire extinguisher to produce thrust. And the fact is if you're going to calculate it based on mv squared, it's going to come up with a completely different calculation than if you use momentum. So one of the two theories is right, and one of the two theories has to be wrong. And the fact is the one that gets the right answer is momentum. Measuring the momentum of your exhaust will tell you how much it's going to move you. Not measuring its kinetic energy. That won't help you any. Shooting bullets out of your spaceship won't work any better than shooting recoiling guns, which is proving that it's about momentum. And we'll hear nothing, no response. Nobody has to explain again how I said anything inaccurate, wrong. Amazing. Yeah, really, it's kind of amazing. Now, it's a limited audience. That's the real problem, right? Because there's got to be a few honest people on this planet who would say, okay, yeah, I can handle that argument. I can explain how that doesn't happen. I can explain, you know, why there's way too much weight on Professor Lewin's cart. No, we don't get anything because the audience is not very useful. Just the truth. All right. So, till the next time and such and so forth and whatnot. Again, like I've stated, is there some special plan here? I mean, am I supposed to do something other than make arguments and have some sense that they should be addressed. You know, if somebody's going to say I'm wrong, they ought to address the arguments. I mean, do you really believe it takes 100 times the fuel to go 10 times as fast? 100 times the fuel. Do you really believe that? Ugh.